So we know that a given set of vectors, v1, v2, all the way to vn, they form what we call a basis of r to the n, if and only if these vectors are linearly independent. And for these vectors to be linearly independent, this has to be the case, that if a1, x1 plus a2, x2 plus all the way to an xn equals 0 implies that these coefficients a1, a2, all the way to an are all 0 themselves. So let's do the problem here to make sense of these facts. So we have a1 times 1 comma negative 1 plus a2 times 1 comma 2. Now this gives us 1a1 plus 1a2 equals 0. And then this gives us negative 1a1 and 2a2. We set that equal to 0. And now we solve this system. These eliminate if you add them. So we have 3a2 equals 0, which implies that a2 is 0. But if a2 is 0 here, then that means that a1 is also 0. And that meets this condition, that if these equations equal 0, then the implication is that the coefficients a1, a2, all the way to an are themselves also equal to 0. So what we have here are a couple of vectors that are linearly independent. So the answer is yes, these two vectors, they form a basis for, in this case, R2. Now your work is sort of the answer. This is just a conclusion, but the teacher is looking for the work. Let's try the same thing, but this time we are playing in R3. So we have a1 times 3, 0, 0, plus a2 times negative 1, 0, 1, plus a3 times 0, 1, 1. Now the equations that we get from this are 3a1 plus negative 1a2 plus 0a3. Always set it equal to 0. And next we have 0a1 plus 0a2 plus 1a3 equals 0. And then we have 0a1 plus 1a2 plus 1a3 equals 0. Looking at this system, if you look at the middle equation, that implies that a3 equals 0. Looking down here, that's not there. Now, if this is 0, then that means that a2 is also 0. So a2 and a3 are both 0. So that's 0, that's 0. So 3a1 is 0, which means that a1 is also 0. And again, as was the case here, we have a1, a2, and a3 all equaling 0. So these vectors are linearly independent. So the answer is again yes. These vectors, they form a basis for R3.